Welcome to the Wine Math series. My name is Maureen Moroney, and in this video, we'll be going through some calculations for amelioration. If you would like to skip the detailed explanation and head straight to an example, you can use the timestamps in the description below to jump to the parts you're interested in. Let's get started. In the case of adding water, we can use a really simple equation for diluting a solution from a higher concentration to a lower concentration. And that works for things like sugar, which we can also talk about as brix. It works for things like acid, and it works for things like alcohol. If any of those are in a higher concentration than you would like, you can ameliorate by adding water to dilute. So the equation that we're going to use moving forward looks like C1V1 equals C2V2. So really simple, but let's take a closer look at what that actually means. C1V1 describes our starting conditions, and C2V2 describes our ending conditions. They're set equal to each other. And C stands for concentration, while V stands for volume. So what we end up having is our concentration 1 times our volume 1 equal to our concentration 2 times our volume 2. So again, fairly straightforward. Concentration 1 times volume 1 equals concentration 2 times volume 2. Now let's put it into practice. Here again at the top we have our equation, and this is something that we use in the lab very often. So I'm going to use a lab example first, and then we'll talk about a winemaking example. Let's say that I have 85% phosphoric acid, and I need 25% phosphoric acid, and I want to make 500 milliliters of it. This is also applicable in a wine lab. If you are running aeration oxidation to measure your SO2, you will need 25% phosphoric acid. So being able to dilute from one concentration to another is very important, not just in winemaking, but in the lab as well. Okay, so using our equation, we know that our starting concentration is 85%. We don't know our starting volume. We don't know how much of that 85% we're going to need. But the information that we do have is that we know our ending concentration and volume. We want to be a concentration of 25%, and we want an ending volume of 500 milliliters. So now we're just missing one piece of information, which is that V1. So that's what we're going to solve for. Okay, so V1 equals our right-hand side, 25% times 500 milliliters divided by that 85% from the left. Okay, so now if we go through and solve that, V1 equals, we can go ahead actually and our percentages cancel out, right? So V1 equals 12,500 over 85 milliliters is the unit that we're left with. And so that works out to V1 equals 147 milliliters. So again, when we solve here for our V1, we're talking about our starting volume of our 85%. That is our starting conditions. So what that means is that we will take 147 milliliters of that 85% phosphoric acid, and we will dilute it up to a final volume of 500 milliliters of our 25% strength. So let's take a look at a winemaking example. In this case, let's imagine that you have 300 gallons of juice, and that is at 28 degrees Brix. But that's a little high. You don't want it quite that high, so you want to dilute it down to 24 degrees Brix. Okay, so let's plug those into our equation here. Our starting concentration is 28 Brix, and our starting volume is 300 gallons. And then our ending concentration, we want to be 24 degrees Brix. And the piece of information that we are missing here is our ending volume. We don't know what that final volume is going to be, so we are solving for V2. So if we go through and do that math, we end up with 28 degrees times 300 gallons over 24 degrees Brix. And again, our units on the Brix are going to cancel out, so we will be solving for gallons. That is equal to our V2. And if we go through and do that math, that works out to 350 gallons as our ending volume. And so what that tells us is that if our ending volume is 350 gallons and we started with 300 gallons, we need to add 50 gallons of water in order to reach that final volume and achieve that 24 degrees Brix concentration. One thing to keep in mind with this equation and with amelioration is that it only works for water because it assumes that you are adding volume without adding anything else, such as sugar, acid, or alcohol. However, if you are adding volumes that are adding a more complex composition, you might be interested in checking out our fortification wine math video in the same series. Thanks for watching this wine math video. If you have any questions regarding the math or the general wine topic covered, feel free to reach out to us at wine@iastate.edu. Check out the other wine math videos to improve your math skills in the cellar. Cheers!